dear students. I hope everybody is doing great. Let's start the numericals based on kinematic equations. Kinematic equations we had discussed and derivations also we have done by using two methods. First method was by using velocity time graph we had derived equations of motion, and number two, by using calculus method, that means by using the applications of differentiation and integration we could derive equations of motion. Alright, now based on them how the questions will be asked, let's check here. The first question. The next 2-3 classes will be completely of numericals, my dear students. The displacement x of a particle at the instant when its velocity v is given by this one. Find its acceleration and initial velocity. Find its acceleration and initial velocity. Look at here. This is so simple, and these kind of questions we can solve by using comparison method. This is the equation where v is velocity and s is displacement. We know velocity displacement. What is the velocity displacement relation? V square minus u square is equal to 2a into displacement is denoted with the symbol x here. So that is x. Okay. So now this equation you can write in terms of this. What is this? Both sides if you apply square, so that will be v square is equal to 3x plus 16. This equation I can write v square minus 16 is equal to 3x. Can I write like this? From here what you can understand. So you can compare these two equations, yes or no? So you can compare this. U square is equal to 16. Understand? So u square is equal to 16. So that means initial velocity is 4 meters per second. Clear? Now you can also compare this right hand side, that is 2ax, and this is 3x. So 2ax is equal to 3x. So x cancel. From here acceleration is equal to 3 by 2. So that is 1.5 meter per second square, my dear children. So there is no other way of solving this question except this. Clear? Understand? Because so there is no concept of time is given. If there is a velocity depending on the time, at least you could do to find acceleration. Acceleration is equal to dv by dt, right? But here there is no chance except the comparison, right? Now let's see one. A body is starting from rest. A body is starting from rest. Immediately you must write its initial velocity is 0 meters per second and moves with an uniform acceleration of 5 meter per second square. This is the uniform acceleration, 5 meter per second square. Whenever in an equation or in a question, if it is mentioned that the body is moving with uniform acceleration, it is confirmed that you can use the equations of motion, right? You can use the equation of motion. This is one and only condition to use equations of motion. The body must be moving with uniform acceleration. Alright? Now, this is moving with uniform acceleration of 5 meter per second square. For how many seconds? For 8 seconds it is moving. Then what happens? From that time, the acceleration ceases. Ceases means acceleration becomes 0 meter per second square from this time. Now, what happened? Let's check. A body is starting from rest. Try to draw the rough diagram. A body is starting from rest. It's moving with uniform acceleration, means it will increase its velocity, increase its velocity, increase its velocity till that point the acceleration is 5 meters per second square, my dear students. At this point onwards, the body is acceleration 0. Acceleration 0 means it must move with constant velocity. So at this point it will acquire some velocity, right? See, from here to here, uniform acceleration means increasing in the speed, increasing in the velocity. Velocity is increases. At this point it reaches to some value, and from this 8 seconds time, this is 0 seconds, 8 seconds it took. From this 8 seconds time, acceleration is 0 means, so the body is moving with constant velocity. Okay, so let me write, it is moving with constant velocity from here to, find the distance covered in 12 seconds from the rest. From 0 to 8 and 8 to, this is 12 seconds. Definitely the body will cover some distance here. So let us say that distance is S1. So the body will cover some distance here. Let us say that distance is S2. The aim is to find S1 plus S2, my dear children. The aim is to find S1 plus S2. See the data given. What is the particular formula and exact formula to be used, and find out the answer. Let's see. Let's concentrate on 0 to 8 seconds. We have initial velocity. We don't know the final velocity. Okay. We have acceleration, and you can find S1. So this S1 you can find by using this formula. So this S1 we can find by using this formula. Look at here, because we don't know V. That's why I could not write the third equation of motion. Alright. So this is S1 is equal to ut plus half at square. If you really look at this, so S1 will be equal to u into t. It is 0 because the body is starting from rest. Half into acceleration is 5 meter per second square into t square. From here to here it is 8 square, 64. It is 2 ones and 2 32s. 32 into 5, it is 160 meters, my dear students. 160 meters is the distance traveled in 8 seconds. Now, the body acceleration is ceased. Ceased means acceleration became 0 here. That means the body will be moving with constant velocity from here to here. But you should know what is that velocity. With what velocity it is moving, you should know. So if you use the formula called V is equal to U plus AT, what is this V? That is, we need to find out. U is 0, A is 5 meter per second square into time. How much time it is traveled from here to here? So it is traveled 8 seconds. So 8 5s are 40 meters per second is the velocity, my dear students. See, I have told you clearly, body is starting from rest. Slowly it is accelerating, means it is increasing its speed. Finally, after 8 seconds, it is moving with 40 meter per second. And from here, it is continuously moving with the same 40 meters per second, my dear students. Same 40 meter per second. But the time interval is given from 8 seconds to 12 seconds, means for this 4 seconds, it is moving only with 40 meter per second. Okay. If you want to use here, if you want to use the formula called S2 is equal to U. Initial velocity is here. I am talking about S2. S2 initial velocity is V, right? So Vt plus half at square. Anyway, from here to here, it's clearly mentioned that it is moving with constant velocity. That means acceleration is 0. So this complete term will become 0. So now I can write it is V into T. What is V here? V with what constant velocity it is moving. So that's what you are 40 meter per second. So constant velocity is 40 into time taken from here to here. The time interval in which the body is moving with constant velocity is from here to here, it's 40, right? Sorry, from here to here it is 4 seconds. So I can say it is 4. So it is also 160 meters, right? So your S1 value from here to here, it is 160 meters. Your S2 value is also 160 meters. What is the total distance? Read the question once again. Find the distance covered in 12 seconds from rest. From rest, find the distance traveled in 12 seconds. What is that? S1, 160. What is S2? 160. So the total distance traveled is 320 meters, which was from 160 plus 160. Alright. Clear? That's it. Like this, the numericals will be asked. Slowly we are increasing the level of the numericals. V is equal to U plus 80. Let us take an example of a numerical. V is equal to U plus 80. See here. By giving U, A, T, finding V, that kind of numericals we are not doing. That kind of numericals we might have done from 8th standard, 9th standard, and even in our basics of equations of motion. Before starting your actual PU classes, we have discussed such kind of numericals. You can go back and watch the videos because they are available now. Okay? Clear? So such kind of problems we'll never solve here because we are not studying in 7th and 9th standards. We have started your first PUC. So your level need to be improved. So that will take place just by your practice. Nothing else. Right? So let's move on to the next question. This is a commonly asked question in a NEET exam or CET exam. Commonly asked question. Commonly asked. The two ends of a train moving with uniform acceleration and pass a certain point with velocities u and v. See, there is a train, carefully see. This is the train. This is front portion and this is back portion of the train. Two ends of the train, front and back end. The two ends of a train with uniform acceleration and pass a certain point with velocities u and v. There is a point here, look at here. Front end will pass this with a speed u, back end will pass this with a speed v because train is moving with uniform acceleration. Speed is increasing. Train is moving with uniform acceleration means it is increasing its speed. So front end like this, when it is moving with front end, it will move with velocity u. When the same point P is covered by the back end, it is moving with speed v. So simple. Right? Now the question is, find the velocity with which the midpoint of the train passes the same point. Midpoint of the train passes the same point. Okay. Let's concentrate the first case. Right? First case. So this is the point P. First case, let us concentrate. So this is the point P. This is the front portion of the train F. This is the midpoint of the train. So front portion of the train is moving with the speed u. It's covering that point with the speed v, u. Question is, find the velocity with which the midpoint of the train passes the same point. Imagine this distance is x. This distance is x. After some time, see, when the train is moving in this direction, after some time, definitely the train, the midpoint will also move, pass through this point with some particular speed. Alright? Yes or no? See, that's the situation I am going to discuss with you now. This is the midpoint of the train. Now, this is the midpoint of the train. This is the end point of the train. See the diagram. A neat diagram I have drawn here. So this is front portion, this is back portion, so this is midpoint. Right? So the midpoint as well as the point P, both are same. it is already covered. This point u, this is already covered with the speed u, and now the midpoint is covering that particular point P with the speed v dash. Imagine that is v dash. What is the distance traveled from here to here? X. X is the distance traveled. Alright. So now the situation is final velocity. Let us use the formula v square minus u square is equal to 2as. Alright. So v square, what is the final velocity here? V dash square minus u square is equal to 2a into x. What is this? This is the final velocity and initial velocity. Between final velocity, I am talking about only from here to here. That means midpoint and the front end of the train. Midpoint and front end of the train. Okay. So front end of the train is moving, passing through the point with the speed v, and next after traveling a distance x, midpoint of the train is passing through the same point with the speed v dash. So the distance covered here, it is x. So that's what I wrote. Final velocity minus initial velocity square is equal to 2ax. Now let's concentrate the another diagram. So the diagram which is after this, look at here, the diagram which is after this. After this, what will be the position? After this, midpoint is crossed this point P with the speed v dash. Okay. Now after this, what happens, so this is your midpoint. Midpoint is not changing. So this is your point P. Now the back end of the train, look at here. Now the back end of the train, this is front end, this is back end, this is midpoint of the train. See, midpoint of the train already crossed this point with the speed v dash. What they have clearly given, the two ends of a train moving with uniform acceleration and past a certain point with velocities u and v. So the back end of the train will pass through this point with a speed v. Okay, so but distance traveled will be x only. Why? Because this is half of the train is x and the other half also will be x. Definitely the other half also will be x. Now in this case, this is the initial velocity and this is the final velocity. Initial velocity is velocity with which the midpoint of the train passing through point P, and final velocity is velocity with which the final end of the train passes through the point P. So from here, if you apply same v square minus u square is equal to 2as formula, let's see, final velocity. So this is v square minus initial velocity v dash square, which is equal to 2 into a into x, because here also acceleration is uniform. Distance covered between these 2 points is x. Alright. Now equation 1 is equal to equation 2. So imagine this is equation 1, this is equation 2. Both right hand side is same. Let us equate both left hand sides. Left hand side, v dash square minus u square is equal to v square minus v dash square. So our aim is to find v dash. Find the velocity with which the midpoint of the train passes through. Midpoint of the train passes through, we consider as v dash. Midpoint of the train passes through the point P with the speed v dash. So now this v dash minus v dash square, take it to the other side. V dash square minus v dash square will take to the other side, that will be plus v dash square, which is equal to v square is on the right hand side and this is minus u square, take to the other side, that will be plus u square. Okay, so now what I can write? So 2 into v dash square is equal to v square plus u square. So from here I can write it as v dash square is equal to v square plus u square divided by 2. And a very important concept, v dash value will be equal to square root v square plus u square by 2. So to solve this in your NEET exam or CET or JEE exam, To solve in this way, it will take minimum of 2 to 3 minutes with a lot of practice. Right? With a lot of practice, a minimum time is required to solve like this is 2 to 3 minutes. To avoid that, there are some formulas which you should remember, which you should recollect. And these are the formulas to be noted down in your formula book. Right? Why? To save your time. With what velocity the midpoint of the vehicle or the midpoint of the train passes through the same point. What is that? If they give the final velocity of the train and the initial velocity of the train, for example, if they give u, that means front end of the train is passing with a speed 10 meters per second. Back end of the train is passing with the speed 20 meters per second, is passing the point with the speed 20 meters per second. The question is, with what speed the midpoint of the train passes through the same point, right? So V dash is equal to square root, so that is 20 square plus 10 square divided by 2. You get some answer, right? With that much speed, the midpoint of the train passes through the same point. Alright? Commonly asked question, and the application is very important, and how we have approached the problem, how we have solved the problem is very important, my dear children. Clear? So let us solve some more questions related to the same equations of motion. Alright, my dear students. Let's have a look at the other three numericals. Number 1. A bullet is fired into a fixed target and loses half of its velocity in penetrating 15 centimeters. How much further it will penetrate before coming to the rest? Clear? A bullet is fired into a fixed target. So let us draw a simple basic diagram. This is the fixed target. A bullet is fired definitely just before entering into the target, it is moving with some initial velocity u. What happened? It loses half of its velocity in penetrating 15 centimeters. So imagine, so this is 15 centimeters. Okay. While coming out from this 15 centimeters, what happened? It is losing half of the initial velocity. Means it became half. Alright. Clear? So how much velocity is lost here? Half. So remaining half is the final velocity. So initial velocity you know, final velocity you know, right? And distance traveled also you know. What is the formula you will use for this? We will use the formula called V square minus U square is equal to 2AS. From this, what is the final velocity here? U by 2 square. U by 2 whole square minus U square is equal to 2 into A into 15 centimeters. Right? So this you can also write it as U square by 4 minus U square, which is equal to 2A into 15. And again you can write this minus 3U square by 4, which is equal to 2A into 15. Right? From here I can also write this as minus 3U square by 4 into 15 is equal to 2A. Let's write it, let's keep it as equation number 1. Why we are writing like this, why we are writing the equation is equal to 2A, you will understand it later. With a lot of practice, you will also understand. By looking at the numerical itself, you will understand. Alright. Now, there is another case. What is the question now? How much further it will penetrate before coming to the rest? Imagine this is the distance I am imagining as x. After traveling a further distance called x, the final velocity is 0. I am imagining that. how much further it will penetrate before coming to the rest. So this x value I need to find out. In the second case, final velocity is how much? 0 square. We are using the same formula, v square minus u square is equal to 2as. 0 square minus u by 2 whole square is equal to 2a into x. Okay. So now here it is minus u square by 4 is equal to 2ax. From here I can write minus u square by 4x is equal to 2a. It is equation number 2. Okay. Can I equate equation number 1 and 2? Because both right hand sides are same, you can see. So if you equate equation 1 is equal to equation 2, so what I can write here? So it is minus 3u square by 15 into 4, which is equal to minus u square by 4 into x. See, u square by 4, u square by 4 cancel. Minus minus also cancel. It is 3 ones and 3 fives. So what is remained? If you really and carefully observe, so you have remained only x is equal to 5 centimeters. So this is your answer. What does it mean? After traveling to a distance called 15 centimeters, the body losing its velocity half. After traveling further 5 centimeters, the body's final velocity is becoming 0. That means it is 0. It is at rest. Right? It cannot penetrate further because its final velocity is becoming 0. Why the final velocity is becoming 0? When the bullet strikes this hard surface, a target, imagine it is a wooden block. When this bullet strikes this wooden block, what is happening here? Slowly there will be opposing force by the block on the bullet. So its velocity will be keep on decreases and finally it will become 0. That's it. Let's have a look at the next question. A car moving with a speed of 50 kilometers per hour. A car is moving with a speed of 50 kilometers per hour. It can be stopped by applying brakes after at least 6 meters. If the same car, see, car is same. If the same car is moving at a speed of 100 km per hour, what will be the minimum stopping distance? Commonly asked question in the NEET exam is also based on stopping distance. So simple. Stopping distance means the body will come to the rest finally. Okay. So look at this interesting equation. V square minus u square is equal to 2as. If you take this equation, final velocity is becoming 0 means definitely you need to apply the brakes. When the brakes are applied, the retarding force you have applied on the body. Retarding force will lead to retardation. That's not the acceleration, retardation. So what I can write, final velocity is becoming 0 minus initial velocity square is equal to 2 into this acceleration. But in this case, when you apply braking force, this is called retardation, that is minus 2 into a into s. So this I can write minus u square is equal to 2as minus, so minus minus cancel, it's u square is equal to 2as. Alright? As the car is same, the mass of the car is not changing. Understand? As the car is same, the same retarding force you can apply. So then this is constant. When it is constant, I can write u square is directly proportional to s. Remember, whenever there is a question based on stopping distance, remember my dear students, immediately you write u square is directly proportional to s. When they are asking only stopping force concept, you apply this formula. When they are asking you to apply only stopping distance distance formula or concept, use this formula. Or if they are asking the relation in the sense in the same car and the stopping distances depends on their velocity. See here, stopping distance is depending on their velocity, initial velocity. With what velocity it is moving, the stopping distance affects. Okay, if they are asking about a same car and the variation in the stopping distance, you have to use this formula directly. U square is directly proportional to S. Alright, now from here you can write it as U1 by U2 whole square, which is equal to S1 by S2. Okay, and what is U1 by U2? U1, see, initial velocity is given as 50, so that is 50 divided by in kilometer per hour, right? 50 divided by, so initial velocity in the second case they gave as 100. Okay, so 50 by 100 whole square, which is equal to S1 by S2. What is S1? It is 6 meters. What is S2? That is what we need to find out. So S1 is 6 by S2. Read the question. So find the minimum stopping distance in the second case. So that is S2 we are going to find out. 0, 0, 5 2's 1 by 2 whole square is 1 by 4 is equal to 6 by S2. From here I can write S2 is equal to 24 meter. Alright. If your answer is less than 6 meters, it is 100% wrong. Because really, when the initial velocity is 50 km per hour, you have got the stopping distance 6 meters. Now when the initial velocity is increased, look at here, initial velocity is directly proportional to S. When the initial velocity is increased, definitely your minimum stopping distance need to be increased. This initial velocity became 100 here and the stopping distance need to be greater than 6 and we have got it as 24 and that is 100% correct answer. Clear? Let's look at the last question of the session. A particle is starting from rest. This is also commonly asked question in the NEET, CET and even for JEE also. Commonly asked question. You check the previous year questions, you will understand. And even 100 numericals, if we solve on these equations of motion, there is no guarantee that you get a question from the similar model. The reason and the answer why we are doing these numericals, and you could see clearly, this is the 6th problem we are doing today. There's no numerical is repeated. Each and every model we are trying to cover. Right? Now, for example, we have discussed this question. You try this question with your own values. That's called the practice. Just change the values and try to solve the question 1 or 2 times. Here also, just try to change the values and try to solve the question 1 or 2 times. So that's called the practice. Here also the same thing. A particle is starting from rest. Initial velocity is 0. It's clearly given here, 0 meters per second. With uniform acceleration, it is moving. Immediately, see here, uniform acceleration means speed is increasing. Uniform acceleration means speed is increasing. Speed is increasing. This is what the flow chart should roll in your mind when you look at the name called uniform acceleration. What is the flow chart need to be rolled? Uniform acceleration means increasing in the speed. That means distance covered is more. Keep on increases. Keep on increases. Understand? Once again. Body is moving with uniform acceleration. That means increasing in the speed. Distance covered is also increasing. Right? In 1 second, imagine initially the distance covered is 10 meters. In the next second, distance covered will be more than 10 meters. And the next 1 second distance covered will be more than that, more than the previous. So uniform acceleration means speed is increasing, distance covered is also increasing with the time. Remember this. Now, it travels a distance x in the first 2 seconds, right? So look at here, body is starting from point A and reaching to the point B in 2 seconds, it's covered a distance x, right? And a distance y in the next 2 seconds, that's what I told you. In the first 2 seconds, as the body is moving with uniform acceleration, in the first 2 seconds it is covered distance x. Second 2 seconds, definitely the distance covered will be more. Understand? This is also the 2 seconds. See the distance covered. It's more, it's y. Right? It is clearly represented in the diagram. And your answer must be, the y value must be greater than x. Right? Your value of y must be greater than x. Otherwise it's wrong. Because the distance covered must be more. Distance covered must be more. Okay. So let's have a look at the question. Imagine the body starting from 0. That's what they have clearly given. The question is, find the relation between x and y. Find the relation between x and y. One relation we found, y is greater than x. That's for sure. Let's check. Concentrate on these two places. Let us use the formula called S is equal to ut plus half at square. In this case, S is equal to ut plus half at square. First case, what is that? X is equal to u into t. U is 0, t is 2 seconds, 0. Half into uniform acceleration into t square. T square is 2 square, it is 4. Right? This is x. Let write it is equation 1. Now, second case, let's focus. Second case, to apply S is equal to ut plus half at square. Second case means only from B to C. To apply ut plus half at square, you need to find the initial velocity here. If you want to apply S is equal to ut plus half at square in this region, you need this u. That u is not there with you. Understand? So that's why let us consider from A to C. A to C, you apply this one. A to C, what is the S value? A to C, S value is x plus y. See, x plus y, which is equal to u into t. At A, initial velocity 0, right? 0 into t. T is the total time from here to here. 2 seconds plus 2 seconds, it's 4 seconds. So, anyway, 0 into 4 seconds, it is 0. Half into A into t square. T square. So, it is 4 into 4. Alright. We'll tell you the interesting thing. Half into A into 4. See here. Half into A into 4. Is it equal to x from the first equation? X plus y is equal to 4 into this value is x. Right? Now from here, y is equal to 4x minus x. So this y is equal to 3x. Look at this interesting thing. So the relation y is equal to 3 into x. If you carefully observe this, y is greater than x. Understand? Y value is how much? 3x. Is it greater than x or less than x? 3x is greater than x. So your answer is correct. What most of the students do, right? Still after listening this, most of the students do. You may be having your friends. You just ask this question to your friends. They'll definitely give answer x is equal to y. Because this is 2 seconds, this is 2 seconds. If what is the distance covered in these 2 seconds, the same distance covered in these 2 seconds, that will be their answer. That's wrong. That is right when the body is moving with constant velocity. Constant velocity means constant displacements covered. That's called uniform motion. This is not uniform motion, it is uniform acceleration. Always this y is equal to 3 times of x. That's it. Okay? I hope you are understanding the numericals, and let's meet once again in the next class with some more numericals. All are advanced kind of numericals only we are discussing, and let's meet in the next class. Until then, shining off, bye bye, and all the very best for your assignment.